Okay, so the question is what is the bias variance trade-off? Explain with real example. So first of all, the bias is error. Bias is error from wrong assumption, and actually, it is the formula is like actual value and predicted value. So the difference between the actual value and predicted value is called a bias. So basically, it is error from the assumption. So yeah, and the variance is basically the error from sensitivity to noise. And the in machine learning the main tension is how to balance between these bias variance trade-off. So basically the this is fundamental tension in machine learning. Okay, so high bias means our model is too simple to capture the patterns. For example, uh, I want to predict the house price, and there are many features to predict the house prices in any city. For example, the area, the size of the space, and location, and also distance from the airport. There are multiple features, but we are using only one or two features, so it is not predicting the good. It is very high bias, so it is called high bias, and high bias result into the underfitting is basically the when we perform the model when we perform the prediction on the training data, so it will give the very high training error, and also when we apply on testing data, so it will give the high test error. So basically the high bias means the training error and testing error both are high. And same as if we increase the high variance, so it will result in the so high variance. It means like the it is it is giving the very good result on the training data. So basically it memorizes all the samples on training data. So training error is very less, but when we perform model on testing data, so it will testing data are new data, so it will give very not good performance. So the testing error is high. So the difference between the training error and testing error in high variance is very high. So it is overfitting. Okay, so yeah, so this is so we need to find the balance between bias and variance. So there are, so for example, if we increase the uh, model complexity, so bias is decreases, but variance is increases. Variance is increased. So we need to find the solution. So for high bias there is many solutions. So for example, if we have high bias problem in our model, so we need to increase the complexity of model, and also we can increase the number of features, and also we need to reduce the regularization. And the fourth is yeah, so these are the solution for high bias, reducing high bias. And the solution for high variance is also like increase the data set, because it's all about the problem is we train the model on very small data set. So if we increase the data set, so overfitting will be reduced. And also we can reduce the overfitting by applying the regularization. Basically regularization is it is just there are it is adding penalties to the loss function. So there are two types of regularization, L1 and L2, and for regression there are Lasso and Ridge regularization. And also we can use dropout rate in and dropout in a neural network. And also we can use very good solution is adding the cross validation, k-fold cross validation. And yeah, so these are the solution for high variance. Okay, so and let's talk about the real world examples. For example, in medical diagnosis, if I want to build a model for predicting the diabetes, and we are, so for example, we are using only two features to predict the whether the person has diabetes or not. So it is very high bias, very simple model. So it will give the underfit model. And when we increase the number of features 500, so it is too much, too complex, so it is high variance. And in also in banking prediction or credit risk model. So that's why we use ensemble methods, basically XGBoost plus regularization, it find the sweet spot in model. Okay, so these are the solutions. Thank you.